Hi, welcome to step 2 in our turret creation tutorial. So in this step, what we're going to be doing is taking our turret that we created in step 1 and adding some script to it to rotate it and point at a target and launch some laser projectiles. So what I'll be doing is going over the script in detail and especially the math part. Now, rotations do require some amount of math, and I take some time to kind of explain how these equations work in order to achieve the rotations that we want, the speed we want, and how smooth we make the rotations as our turret rotates toward our target. If you want more information on how some of this rotation functions work in a bit more step-by-step fashion, you can check out my other tutorials specifically covering lerp functionality in Unity and some of the other functions on quaternions and kind of how they work and how you can use those to rotate your objects. So why don't we put on our programming glasses and get looking at some script. So if you watch the first step in this tutorial, you'll see that we had made a turret blaster in Blender and we had brought it into a Unity project into a scene in my base tutorial Unity project that I've used for other tutorials. So we can see the turret blaster in the middle of my blue field here. So what we're going to do in this scene is to add a couple things. First of all, we are going to add a script. So I've made a basic script that I'll be reviewing and assign it to our turret blaster to allow us to move the top, rotate the top, and rotate the guns up and down using the keyboard. I like to use the keyboard when testing things out just because you have control over what's happening and you can see exactly what happens when a certain action takes place, and it's very easy to control. So what I'm going to do is kind of review that script right now, and then we'll assign it to our turret and see what happens. So let's bring up our script in Visual Studio. So what we have here is a couple things at the top. So you'll see the very first thing I do is have an enum. So if you're not familiar with C# enums, it's really just a set of definitions that can be assigned to and checked. It's really just the same as using a number, but it gives them names so it's easier to follow what's going on. And so what we really have in our turret, and we won't be using them all up front, but we have certain states that the turret will be in. And as we go into more automation control of the turret, I'll go over those states. But this enum basically allows me to set those states. Next, inside of the class, what we have is a group of serialized fields. So what I would suggest when you do things for the first time is you write them in a generic way so that you can use them again for other objects. By externalizing all of these fields, I can draw any number of turrets with any number of guns and a wide variety of behaviors that I can set all through these serialized fields. So it's a good idea as you build up a library of game components that you make them as generic as possible. So what we have here is the first one is going to be the turret top. And if you remember, we made our blaster turret in 3 pieces. We have the base, we have the top, and we have the guns. We did that specifically so we could set them and control them independently. So the first thing we have is a game object, which is a turret top. We have the turret guns. We have a list of fire points. So I'm going to want to launch some lasers out of this turret blaster, and I need to know the position of where those lasers will start from. And so what I need is I need the points. And I could make a separate game object for each point, but by making it a list, I can give it any number of fire points. I could make a turret blaster with 1 gun or 4 or any number, and this will still work. So, good idea to make it, again, more generic. I need a game object for the laser bullet that's going to be launched. What I added here is this distance tracking object. So I'm going to be setting the radius right here for when I want to detect an enemy that I want to shoot at. Now, when you're laying this out in a scene, it's difficult to know exactly how far that distance is. So by adding a distance tracking object, and you'll see how I use it, it can help there. So I have the speed of my laser blast that I want to send out. I have a tracking tag, meaning I'm going to tag each one of my enemies so I know who to detect in my scene and who to fire at. Again, I have this radius of how far out I want to track the enemies. And then I have the rotation speed. So when it rotates, again, when we get to the automation rotation, how fast do I rotate toward that object? All right. There's some other variables that I'm hiding that will be used for step 3. So at the start, what I need to do is I need to save, set up a couple things. So what I need to do is I need to get a list of my targets. So you can see what's happening is I'm finding game objects with tag. Again, using that tracking tag that we set up there. So now I have a list of targets that I can find. So before I go into all of these details, because these are used more for a little later in the tutorial, what I'm going to do is I'm going to go over what happens in update. So in update, I have this function called process keys. So what I'm doing here is I'm really just reading the keys from the keyboard, and I'm going to take some action on my turret. So this way, what I can do is I can test out to make sure all my rotations are working as expected. So when I hit the W key, these are pretty common keys for using for control on the keyboard. W will rotate. It'll take the gun, the turret gun, and it will set its Euler angle. And remember, the transform, I can set the rotation based on the angle. And remember, we created the object so I can rotate it up and down without it moving. And what I'm going to do is I'm going to take the current angle and subtract 10 from it. So basically it will move up, because up is in the negative direction. And I'm going to keep the Y and the Z exactly as they were. So when I press the X, I want it to go down. I'm going to add 10, and this is in degrees. So I'm going to add 10 degrees in the X, around the X-axis. So that will tip it down. And again, the Y and the Z stay the same. When I hit the A key, I'm going to rotate the turret top. But this time I'm going to rotate around the Y-axis. And I'm going to make it go in the negative direction, which is counterclockwise. And when I hit D, I'm going to do the same thing around the Y-axis of the turret top, except in 10 degrees in the positive direction. If I hit escape, I'm going to quit my app, and a space is going to fire one of my laser bullets. So if we look at what the add laser bullet does, is it loops through all the fire points. Remember, that's a list. And it's going to create the bullet. It is going to transform the direction of the bullet, because the laser object is long and narrow, and so what I want to do is I want to rotate that object in the direction that it's going to fire. Then I am going to move its position to the fire point, and I'm going to add a little bit onto it, because the position of the bullet, I don't want it to be inside the gun at the start, I want it to be a little bit ahead of it. And so you'll notice that this transform direction, I added 0.2 onto it to move it a little bit ahead. Then what I need to do is I need to move it. So I want to get the direction that the guns are pointing toward. So I use this transform direction, and I want to add to it the bullet speed. So this, I'm going to use this as a velocity. So I want the velocity to move in the direction in the X and Y rotation. That's the same with the guns. And then I want to move it ahead. The Z direction, remember, is always forward. So that's important to remember. And if some of this is confusing, I did a different tutorial all on how these rotations and transforms work. So you might want to watch that. That's why I made that ahead of this one, because some of these concepts can be complicated. Then what I can do is I get the rigid body of my laser bullet, and I set its velocity to be equal to that direction to shoot. So in this way, it's going to create the laser bullet and set its velocity to go forward in the direction that my guns are pointing. Then the last thing to do is I actually use the angle of the bullet itself, and I rotate it to match the rotation of the gun. This is actually what rotates that oblong. The other one, this one is simply set up for the direction that it's going to move. All right. So let's go back to Unity. And what I'm going to do is I'm going to come up here. First thing I got to do is I have to add those fire points. So what I'm going to do is go to the top. It's easier to be in, if you don't know, I can go into non-perspective mode. I can't remember what that's called. And what I'm going to do is zoom in a bit. Going to create empty objects. Remember, I don't actually want an object to appear here. What I do is I just want an object itself. I'm going to move it right to the front tip of the gun there. I'm going to create another one. We'll move this right up to the tip here. I'm going to go to the side view to check to make sure that it's the right height, and actually it surprisingly is exactly the right height. Not sure how it picks that height by default, but it picked the right one. So we have our two fire point objects, and because they're children of the guns, it's good. They will rotate. Remember, children are always their position is always going to be relative to their parent. So as the parent moves, they move with it, which is exactly what we want. Remember, our guns move with our top because the guns are a child of the top, and the top is a child of the whole gun turret base. So as the base moves, the top moves. As the top moves, the guns move. As the top rotates, the guns rotate. All right. So let's come in here. Let's add a component. Let us go to scripts. Let's add the blaster turret script. And now what I need to do is I need to set all of our serialized fields that we have in our script. So I need to just grab this top, drag it into turret top, grab the guns, drag it into turret guns. For the fire points, I need to hit this plus to add two elements to our list. I can grab our game objects, drag them in there. Here's our second game object, drag her in there. For my laser, I have this laser bullet that I've made. If you want to know how I made this laser bullet, you can look at the third step of the Spaceship Blaster game. I just grabbed the laser bullet from that game to use in here. Again, It's handy after you make some of these components, you can actually reuse them in other games. So it comes in handy, but I do go over all the steps I use to make that if you want to know that. Let's set our speed at like 30. So it's going to be like 30 meters per second. Tracking tag, I am going to use just the word tracking. The radius I'll make 30, and the rotation speed I'll make 50. All right. So the tracking radius, rotation speed, tracking tag are not going to be used for this first step. And I'm not using the distance tracking object right now. All right. So let's run this guy. See if I remember to do everything. And it looks like I did not. Oop, that is why. Because I used the wrong... I actually used the term target for my... I did not do a null check before I saw if I had any targets in my list, which you should always do. All right, so I am going to hit the W key, and we see our guns are going up and down just as they should. I'm going to hit the A key, and as I hit the A key, we can see that I'm rotating the top as it should. I'm going to hit the space key, and we can see our lasers are firing. A little slow, aren't they? So one thing you can do is you can, while you're running, right, we can adjust this. So let's make it 60. Let's double those. Yeah, that's better. Now, what you got to remember is, if you'll notice that this 60 here, when I stop, see, it goes back to 30. So they're just temporary. Anything while you're running and debugging is only good for that debug session. But it's handy to play around with things, and you can actually try things out and change it and see the result quite quickly. So then you can figure out how to set all your values. And that's the other advantage of these serialized fields. All right. So we have our object is rotating as we expect using our keyboard. So now what we're going to do is I'm going to go over the little trickier part, which is the part of the code that automatically finds and rotates toward a target. So I have these auto rotate variables. And I'm not going to go over, a lot of these are not needed for this. Some of them are. So what I have is I have this current rotation. So what I'm going to do is I need to have a number that goes between 0 and 1 because I'm going to be using the lerp function, actually the slurp function. And I also covered this in my rotation tutorial. And it requires a start angle and an end angle, and then an index value that's going to be between 0 and 1. 0 means it's at the first angle, 1 means it's at the second angle, and some number in between. It will translate between the two based on that number. So that's what this current rotation is. And then the rotation angle amount is the total amount that I'm going to want to rotate. So I use that in one of my calculations that I will go over. So I'm just gonna, I put regions around things a lot of times just to help organize your code and keep things out of the way that you don't really need to worry about at the time. So let's go over what we do in start here. So what I do is this distance object, if I had one, I would instantiate it. I don't right now. I am going to set that position. I'm going to set the material to semi-transparent. All right, so that's just the distance tracking object work. So what I need to do is I need to check my tracking status. So my state, I start out with no track. Basically, I'm not tracking any object currently. And I use these again in step 3 to know where my starting rotation is. So I call it neutral rotation, and it's a quaternion. Because the lerp and slurp use quaternions, and remember the rotation of a game object is a quaternion. So I create 2, and I'm going to set those just to know how do I rotate back to what I'm calling the neutral or starting position. These are used later. So now in the update, in addition to processing the keys, I'm going to do a couple other things. We're going to collapse this. So basically I'm going to say, what is my state I'm in? So if I am in the no track state, what I want to do is I want to find a target. Again, this find target could be anything. I could use any criteria. I am doing a very, very simple criteria, but you can add and make whatever complicated criteria you want to decide who you should fire at. In this case, I have a function to do it find target. We'll go over that in a minute. So I'm going to get the object being tracked. If it's not null, meaning if I found no target, it's going to be null, and I just go on my merry way and I exit. But if it's not null, I'm going to change my state to rotating to object. So I'm currently rotating to point at my object, my target that I found. And then first thing I'm going to do, and this is the most complicated, I'm going to load these rotation angle amounts. So I'll go over that function because that's probably the more complicated part of this whole process. And then I am going to save, before I do anything, I'm going to save my neutral top rotation and neutral guns rotation so I can rotate back to it. I'm not going to be doing the rotate back at this step in the tutorial, but I will need to save that for later. All right. So let's go over this load rotation angle amounts. I'm going to hit F12, very handy shortcut key. I'm going to collapse our laser bullet. So this is generally the trickiest part of rotating and using the lerp and slurp functions are how to compute that index between 0 and 1 to achieve the rotation you want. So in order to figure out what we want to do, we have to think, how do I want my turret to behave? And so I'm going to kind of go over my thought process of how I went about figuring out how to do this. So this is kind of what I thought of when I decided how I want to control that index that goes between 0 and 1. One, I want a constant speed. So this means that no matter how big my angle is, I want the speed of rotation to be the same. So if I'm rotating, say, 90 degrees, that takes 1 second. I want 45 degrees to take a half a second. The smaller the angle, the quicker it's going to reach there if it's a constant speed. Of course, makes sense. The larger the angle, the longer it should take to rotate. That makes sense. So when I'm computing my steps, as my index goes up, I want it to take smaller and smaller steps based on the size of the angle. And the size of the step is going to be linear to the angle size. So figuring out the relationship between what you're using to control your rotation index and the rotation amount is important. And if you can get something that's linear, that is always very helpful because it creates a very simple formula in order to use when computing that rotation step. And you'll see how we use this in the code. But essentially, my step is going to be the amount of time that's elapsed since my last step times the speed of rotation divided by the angle. So the larger the angle, the smaller the step. What this allows me to do is to get an even constant speed. So if you think of it, if my speed of rotation is 90 and my angle is 90, when my time reaches 1 second, the result of this will be 1, right? And when time is a half a second, the result of this will be 0.5. So if I set my speed to 90, then I will rotate 90 degrees in 1 second. Essentially what this does. The other thing is that I have to compute my angle that I want to rotate to. And so what I do is I take the direction that I want to move to and I convert it to an angle. And a direction really is just the difference between the 2 points. In this case, this point is 0, 0, which is the simple case. And if I'm pointing to an offset of x and y 2, 2, then of course that would be a 45-degree angle. And you can see what function that unity provides in order to get that angle. So some of these math concepts is what makes this a trickier part, and you have to get comfortable with these in order to make everything work correctly. All right, so we're back in the code. So here's this load rotation amounts. This is what we are going to do to compute the numbers that we're going to use in our lerp function. So remember I talked about this direction. So I'm going to compute the direction by taking my current the position of the object that I'm being tracked and subtract my current position, and then I'm going to normalize it. So normalizing just means to make a 1 unit long vector. So generally this is needed when using a vector as a direction. So this gives me the direction that I want to point to. Then the quaternion has a function called look rotation that uses that direction vector. And I just want to take the y component for the rotation amount. So this is going to be how much do I have to rotate the top to point at my target. If it's greater than 180, I take 360 minus it, because lerp only works between 0 and 180. Whether you go in the positive direction or negative direction, it always goes between, it can't rotate greater than 180. So if it's greater than 180, I want to make it between 180, and that's what this does. Next thing I want to do is I want to do the same thing for the gun angle. So I take and again use my quaternion look rotation, but then I grab the x version of this because the guns rotate up and down around the x-axis. I only want my guns to rotate between 0 and 90. They're at 0, they either go up 90 degrees or down 90 degrees. So I limit it there. Then what I'm going to do is I'm going to take the larger of the two. So what I do is I want my top and my guns to rotate and reach their destination at the same time. So I want to use the exact same value for stepping that. So you imagine if the top rotates a large rotation and the guns rotate a small one, the guns are going to be moving slower than the top, but the larger the two will always be constant. So I've computed this current rotation value, which is what I'm going to use in my formula. Oops, I mean my rotation angle amount. My current rotation is the current step amount. My rotation angle amount is going to be the size of my angle that I want to rotate. All right, so let's go into the only other function we got, and this is rotate to target. So this is going to be called every single time from update. So what I'm going to do is I want to get the elapsed time. My current rotation, I want to add my rotation speed, remember our formula we were just looking at, we take our rotation speed times the current time elapsed, and that is going to be my current rotation amount. This current rotation amount is going to be something between 0 and 1. So what I want to do is I want to keep track of my target as we rotate. Because if my target's moving, I don't want to rotate to where it was at the start. I want to always change my rotation amount based on if it's moving. So I don't, by the time I stop rotation, I want it to be pointed to where the target is at, not where it was when I started rotation. So I am going to constantly look at my target if it's moving. All right. So what I'm going to do is I am going to get my angles. What angles do I need to get at the target? If the target's not moving, which is a simple case, this is always going to be the same. And my end angle is going to be my target rotation, right? And I want to set my angles to be the y component of the current turret top. Then what I need to do is I need to do my lerp function. And I start rotation at 0, it's going to be my neutral rotation. And at 1, it is going to be my target rotation. Basically what this is doing is you'll see I'm zeroing out the X and Z values to make sure it only rotates around the Y axis. I don't want my turret top to rotate up or down or any other way. I just want it to rotate around the Y. So I zero out those other two for my target rotation. And then again, you'll remember I take my current rotation, which was the rotation speed times time, and divide it by my angle amount. So this gets me my constant speed. And I set my turret top transform rotation to be equal to that. So at the start, I'm going to ignore the guns just so we can see what happens just with the top. What I'm also going to do is once my rotation divided by my rotation angle amount, basically this is my index. If it's greater than 1, then I want to go back to no track, because that means once I reach 1, I've reached my target. All right, so what I'm going to do is build this. I don't think we needed to build it, but just in case, I'm going to come back in here. I have this cube that I've set up, and you can see that it's tagged to be target, which is the target, that string that we set in. I'm gonna make sure it's within our tracking, and I'm going to run. I wonder if it's too far away. Oop, there we go. Wasn't close enough. And again, what I can do is I can move this, right? And our tracking will still work. If it's outside of that radius, it's not going to point toward it. So let's move it up. So see, it's outside the radius. Oops. So now it's not tracking it. As soon as we go down, doop, we can see right when it passed inside the radius, because then it turned. Let's go down. Let's see how close we can get it. Oop, there we go. All right. So the rotation's kind of slow. So what we can do is, even while in here, we can go to the rotation speed. Let's double it. Let's go to 100. Let's grab our cube. Let's move her over here. Oop, it's still within that 30 degrees. Yeah, that's a lot better. You can see it as I'm moving and it's tracking. Remember, it keeps looking at it, so it's going to keep moving with my target. All right. So let's adjust our guns. So let's go in here. Let's uncomment this and we'll take a look at what the turret guns are doing. I'm just going to do a KU for uncomment. I do a lot of commenting and uncommenting as I'm debugging my code. So the guns are going to do a look at the target. And they are going to do the same thing. It's going to use that same filtering out. But in this case, what I'm doing here is it is taking the X value and I'm going to rotate it by the same amount as my turret top Y. And then I'm going to set my Z to 0. So it's going to rotate around the Y the same as the top. I'm trying to think of why that was necessary. I'm surprised. I haven't looked at this code in a while that this would be necessary, because I would think this should be 0. We'll try to zero that out and see what happens. All right. And then what it's going to do is it's going to do the lerp. It's going to set the gun rotation, again, using that same value. And then it's going to load up the Euler angles. Oh, see what it's doing is it's actually only using the X value. I must have done this at different times. So it really didn't, you need to use that Y value here. It could have zeroed that out, but it really doesn't matter because I'm only loading up the X value of the gun rotation anyway. All right, so let's build that guy. Let's go back to our Unity. It's going to compile the scripts and let's move this guy up a bit and let's run. It's up a little too high. You can see the guns are going up and down. What we're going to do is I'm going to make that radius a bit bigger. Let's make the tracking radius 60. That's 60 is pretty big. So you can see it is rotating up. Oop, I'm finally outside the range. Let's move it back here. Let's run it just so we can kind of see it all run together. Great. Now I'm outside of that again. Oh, you know what I did is I changed this back. Remember? All right. So you can see that the guns rotated up at the same, and by the time the guns rotated up, the top was rotated around. But the guns moved up pretty slowly because, again, it looks better than the guns reaching their top and then rotating, that they kind of all rotate together. Let's move this up a little higher. So let's get a little bit more movement. Oops, go back to here, change my tracking radius to 60. All right, looking pretty good. So that pretty much is it for step 2. It's one of the more complicated ones. On step 3, what I'm going to do is after it reaches its target, and it'll track the target, and if the target moves out of range, it'll rotate back to the neutral position. And then we'll add a bunch of targets and then actually add firing the bullets at the target. So By the end, we'll have a lot of targets moving around and watch this turret blaster rotate, blast them, and then rotate back, and then until it finds another target to track. So that will be the conclusion. So stay tuned for step 3, where we complete going through the whole script of our turret blaster. Thanks for watching, and if you like this, give it a thumbs up. And again, I have lots of other tutorials. That's the focus of this this channel, is really to learn how to make Unity components and integrate them into games. So please subscribe to the channel, check out my other videos, and happy gaming.